Hello and welcome to In Depth. I'm Tina Jha. It's been over 3 days that Chandrayaan-2's lander Vikram lost contact with its ground stations, but the Indian Space Research Organization has not lost hope. The space agency's team is making all efforts to restore communication with the lander at ISRO Telemetry Tracking and Command Network in Bengaluru. On Monday, hope revived for crores of Indians after the lander was spotted by the onboard cameras on the orbiter. Images showed the lander is intact, lying in a tilted position with rover Pragyan possibly still confined inside. But despite what happened to the lander, Chandrayaan-2 mission achieved 90 to 95% of its objectives. The orbiter is healthy, safe, and in lunar orbit. It is expected to provide extensive information about the moon and also what minerals and water it has. In Depth today, we'll focus on the key takeaways of India's second lunar mission, the hits and the misses, and the prospects it holds out for the future missions. Space experts and media across the globe have also called the loss of moon lander Vikram as nothing more than a partial loss. But now that the lander has been spotted lying in a single piece, ISRO scientists are holding out hope and continuing efforts to revive communication with it. The Indian Space Research Organization is trying to establish contact with Chandrayaan-2's lander Vikram, that is currently lying on the lunar surface close to the planned touchdown site after a hard landing. Images sent by the onboard camera of the orbiter showed the lander in a single piece, although in a tilted position, with the rover Pragyan seemingly still inside.
As per the information given by ISRO, there are 2 to 3 good updates. One is that yesterday we got a thermal image which had identified the Vikram lander onto the surface of the moon. Today it has been identified that the Vikram lander had landed very close to the predetermined area of a landing. That's a good news. That means the travel has been satisfactory. And the other news is that the lander is, even though the hard landing has taken place, lander is available in one piece. So that indicates that even though the hard landing has happened, the impact is not that severe.
Vikram was located by onboard cameras on Chandrayaan-2's orbiter a day after it lost communication with the ground station during its final descent, just 2.1 kilometers above the lunar surface. ISRO Chief K. Shivan has said that efforts to restore communication with the lander will continue for 14 days, which is the mission life of the lander. However, chances look bleak. Former scientists and experts say that even if the lander and the rover are intact, they would not be able to transmit any scientific data without communication with ground stations. The inverted or tilted position reduces the possibility of re-establishing contact with the lander, since the antennas had to be pointed towards the ground station or the orbiter. There is also a possibility that the impact may have damaged the lander.
The craft was somewhere around 2.6 kilometers or so from the ground of moon. The craft was upside down, which means its legs were pointing up and his head was pointing down. That was never the configuration. That should have never happened. If the legs were pointing up, it means the rocket will be firing like this, and this would have gained velocity downwards. Okay, so this should have never happened. But after that, we see that it is tilting back to its normal position. But by the time it would have actually gained speed, and then it should be falling down. Second thing that we also see is that while the ISRO is saying that at 2.1 kilometer, they lost communication, the telemetry data was seen in the control panels up to when the craft was at 335 meters. So 335 meters above the ground. So when it was about 335 meters above the ground, the vertical velocity, that is the velocity of coming down, was about 59 meters per second. 59 meters per second is a huge number. when it was around 300 meters, the velocity should have not crossed maximum 5 meters per second. This is 59 meters per second. So more than 10 times, more than 12 times, right? So it is not a normal behavior.
Lander Vikram carried 3 payloads, including the radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, Chandra's surface thermophysical experiment, an instrument for lunar seismic activity to conduct surface and subsurface science experiments. The rover Pragyan also had 2 payloads to enhance our understanding of the lunar surface. So far, soft landings have been achieved by the US, the erstwhile Soviet Union and China.
22nd of July. Earlier it was supposed to take off on 15th of July, but at the last moment we have to stop the launching of a mission, essentially because the GSLV Mark III vehicle had developed certain amount of a snag. But the most interesting aspect is that within 1 week, ISRO identified the snag, and more importantly, they rectified it also, and a very successful mission took place on 22nd of July. This essentially indicates that GSLV Mark III, which is a very new vehicle, is now reaching to a level of full operationalization. So this is a good aspect because all our future missions are depending on the success of a GSLV Mark III, and this mission demonstrated very clearly that GSLV Mark III is a good vehicle.
Chandrayaan 2 was successfully launched at 2:43 p.m. on 22nd July. The spacecraft entered the moon space after leaving the Earth's orbit in the dark hours on 14th August after a crucial maneuver called trans-lunar insertion. The spacecraft entered the lunar orbit on 20th August after the lunar orbit insertion maneuver. On 2nd September, Vikram successfully separated from the orbiter, following which 2 deorbiting maneuvers were performed to bring it closer to the moon. And on 7th September, it successfully completed the rough braking phase but lost communication with the ground stations during the fine braking phase. Bureau Report, Rajya Sabha TV. The good thing is that the orbiter will now have a lifespan of over 7.5 years and not just 1 year as was being said earlier, as there is a lot of more fuel left in it. More details of the success of the Chandrayaan 2 mission in our next report.
In the final analysis, Chandrayaan 2 achieved 95% of its mission objectives. What's more, the additional fuel left on board its orbiter and the efficient mission management that launched the GSLV Mark III has ensured the orbiter an additional life of nearly 7.5 years. It was originally planned for just 1 year.
90-95% of the technology demonstration already we are done. So in total, the Chandrayaan 2 mission, it is very close to 100% success. The lifetime was only 1 year. Yes. But because we have the extra fuel right now is available in the orbiter, that at present the orbiter life is estimated as 7.5 years. And the science, whatever we are going to do, it is not only 1 year, it is going to be for 7.5 years.
The orbiter is already in its intended orbit around the moon. It will enrich the understanding of the moon's evolution and map the presence of minerals and water molecules in the polar region using 8 state-of-the-art scientific instruments. The orbiter camera is the highest resolution camera of 0.3 meters in any lunar mission so far and will provide high-resolution images that will immensely help the global scientific community.
What the speciality of this 7.5 years for this science is, what I talked to us about that high resolution, the camera imaging, that is that the swath is small. So because of the long duration, that we will be able to completely cover the entire globe of the moon.
The orbiter is orbiting the moon at an altitude of 100 kilometers. The orbiter is a box-shaped craft with an orbital mass of 2,379 kilograms and solar panels capable of generating 1,000 watt of power. It will communicate with the Indian Deep Space Network. One of its 8 instruments is a laser retro-reflector from NASA, the only foreign payload in the mission.
The basic job of an orbiter is to do a mapping of the moon surface. Essentially what we are trying to identify is what are the minerals which are available on the moon surface, right from bauxite to granite to various other minerals which have been already identified. So assessment of the minerals of those on the moon surface will be carried out. Other aspect is that there is going to be a study of a substance called helium-3. This is supposed to be one substance which will allow you to ensure that the energy security issues get resolved. Because if you get helium-3 back to the surface of the earth, then it will help you to boost up your energy security environment.
See, orbiter and the lander, there is no direct connection. The orbiter and lander separated. After that, the orbiter is an independent object which is going around the moon. It will continue to do all the scientific work that it is designed to do. Okay. For example, there were 4 major scientific objectives of the orbiter. Number 1 objective was to find water in the form of ice on the surface of moon, particularly in the south polar region. Okay, so people say that the ice can be in 2 ways. One, it can be in craters where there is no sunlight. Second, it may be under the soil. The SIR radar that the orbiter is carrying can detect ice wherever it is, even if it is hiding below the soil in subterranean surfaces. It can penetrate up to 5 meters and find out.
The orbiter is expected to provide data about the lunar surface with its terrain mapping camera too. The Chandrayaan-2 Large Area Soft X-ray Spectrometer will measure the moon's X-ray fluorescence spectra. It will look for the presence of major elements like magnesium, aluminium, silicon, calcium, titanium, iron and sodium. The solar X-ray monitor that observes the X-rays emitted by the sun and its corona measures the intensity of solar radiation in these rays and supports class. The orbiter high-resolution camera, on the other hand, will provide high-resolution images. The imaging IR spectrometer will map the presence of minerals on the moon. The dual-frequency synthetic aperture radar for high-resolution lunar mapping in the polar regions will estimate the presence of water ice in the polar region as well as its thickness and distribution. The Chandrayaan-2 Atmospheric Compositional Explorer 2 will study the composition and distribution of the lunar neutral exosphere. Bureau Report, Rajya Sabha TV.
Whenever an ambitious endeavour is undertaken, be it in any field of life, some setback is anticipated. So when ISRO launched its Chandrayaan-2 mission, the expected outcomes were huge. But there was also the challenge of achieving a soft landing on the lunar surface, which has previously been successfully done by only 3 countries. So despite the fate of the lander, Vikram, so far being unknown, there are several positives that have come out from the mission. And this includes the orbiter, which made up to almost 95% of the mission objectives successful. Let's take a look at what we have and will achieve from this Chandrayaan-2 mission still.
Science is anything but predictable. In fact, the present world has been shaped more by accidental discoveries and inventions in science than by expected results. Be it the discovery of penicillin or the invention of the non-shattering safety glass of vehicles, we have scores of examples where a seeming setback at the beginning has turned out to be a path-breaking revelation of hidden treasure. And this aspect of science is exemplified by the Indian Space Research Organization, like many others. In just 50 years since its formation, ISRO has joined an elite club that has members like America's NASA, the European Space Agency and Russia's Roscosmos. Today, ISRO is known for its brilliant yet frugal technology that has sent missions to the Moon and the red planet Mars. Chandrayaan-2 was part of the long line of ambitious endeavours that ISRO has undertaken, most of them successful. Among its main objectives was the very challenging soft landing on the lunar South Pole that would have catapulted India into a rare league of 4 nations that have managed to soft land on the moon. But the failure to make a soft landing cannot possibly hide the long lists of achievements that this mission has already registered. Despite the inability to communicate with the Vikram lander, there are many commendable successes for Chandrayaan 2. Through this launch, ISRO has successfully initiated the operational service of its most powerful rocket, GSLV Mark III. The rocket has a carrying capacity of 4,000 kilograms, which can be commercialized. Also, the precise placement of Chandrayaan 2 into orbit saved sufficient fuel of the orbiter, giving it a prolonged life around the moon. The orbiter was earlier predicted to have a 1-year lifespan, but it could now go on for 7 years. This is similar to the Mars Orbiter mission or Mangalyaan, which was destined to serve for only 6 months but is now close to celebrating its 5th birthday. Chandrayaan 2's orbiter carries major scientific payloads of the mission, with 7 of the 13 major instruments in the entire assembly residing inside it. The camera and spectrometers that the orbiter carries can offer insights into the origin and evolution of the moon. It will also generate a 3D terrain map and study the distribution of various minerals, including magnesium, iron, calcium, and aluminium, among others. In fact, the orbiter has already sent a number of images of the moon's surface and also captured what is believed to be the lander Vikram. The huge amount of data generated by such missions keeps yielding results for a long period of time. All said and done, Vikram did get extremely close to realizing a soft landing that in itself provides many lessons. It is globally acknowledged that soft landing is an extremely complex process, and around 48% of the missions attempting such a touchdown have failed.
See, if you look at very carefully, the statement ISRO has been saying right from 7th morning is, we will learn from this setback. What do you mean by learn from setback? You have to know what exactly happened in the setback. Why the setback happened. Okay? So, in the last 3 minutes, what happened? We know some parameters, like how fast it was going, in what direction it was going. Some parameters are available. But we need to know more. Only then we will be able to find out what went wrong. So, next time we can correct this mistake.
The world has also closely watched the events relating to Chandrayaan 2, sitting up and taking notice, and has acknowledged its many successes, even showing its willingness to work with ISRO. Another positive result of Chandrayaan 2 is the knowledge that a mission as complex as this one can be relatively inexpensive too. The mission has cost the national exchequer less than 1,000 crore rupees, which is less than what it took Hollywood to make the Marvel movie Avengers Endgame. Chandrayaan 2's payload will enable a better understanding of the moon, including water on its surface and the dynamics of harnessing such material and energy resources, of modalities of setting up bases on the moon, of the science behind the creation and evolution of the moon and possibly the Earth too, and a number of technologies that will assist in our deep space missions in the near future. Then there is the immense motivation and inspiration it gives our younger generation, egging them on to not be afraid of failures, to always look at the positive side, and giving them the drive to become future scientists, explorers, entrepreneurs, and investors. With inputs from Vipul Agrawal, Bureau Report, Rajya Sabha TV.
So notwithstanding the minor hiccup in its Chandrayaan 2 mission, ISRO has many plans lined up for the near future and beyond to boost innovation and galvanize the high-tech aerospace Indian industry. ISRO's scientists have already said research and work on future missions will continue as per schedule. So in our next report, let's take a look at what the future holds for ISRO.
The flagship program, that is Gaganyaan project, it is, we are working very seriously to get the first unmanned flight by end of 2020. And like that, we have many other projects. Our hands are full and we are extremely busy with those activities.
Coming months, ISRO has its plate full with space missions targeted at the Moon, Mars, Sun and even Venus. The Aditya L1 mission is ISRO's first planned probe to study the Sun's corona and its atmosphere. It will be launched during 2019-2020 on a PSLV rocket from Sriharikota. Corona, the outer layer of the Sun, extends thousands of kilometers above the visible disk around it. It has temperatures over 1,000,000 degrees Kelvin. The Sun's surface is around 6,000 degrees Kelvin. ISRO's Aditya L1 will attempt to answer how it gets heated to such high temperatures.
Major deep space mission that ISRO is planning is a project called Aditya. It's called Aditya L1 technically. Aditya, the name itself tells you that it is something to do with sun. I mean, this project is to study the sun. Sun's corona, sun's upper layer, the formation of various factors on the surface of sun. This is what it's going to study. Where it is going to be placed, that's a very, very interesting thing. Suppose you assume this camera is the sun and I am the earth. Okay, if there is some object here, the earth's gravity will pull it, the sun's gravity will pull it, right? There is a point between sun and earth called L1 where the pull of earth and the pull of sun is exactly same. So we are going to launch and put the satellite here. So then it means what? When the earth is going around the sun, this will also go around the sun in the same, along with it. So if earth takes 365 days, this will also take 365 days. So always this will be between earth and sun. So which means you are measuring things while it is coming from sun. On earth also you can measure. So you can know the difference. You can do lots of studies with this kind of object. So that's a very complex mission, putting it in L1. That's an ambitious plan that ISRO has for future.
ISRO's plans also include the launch of AstroSat-2, a second observatory in space, by around 2020. The observatory will replace AstroSat-1. It will try to discover new planets and help us understand the origins of the universe. The human spaceflight program Gaganyaan will be ISRO's planned attempt to send 3 Indians to space by 2022 and bring them back safely. The Indian crew orbital spacecraft Gaganyaan will make India only the 4th nation in the world to accomplish the feat. It will be launched on ISRO's biggest rocket, the GSLV Mk3, from Sriharikota. Gaganyaan's crew module to house the astronauts, its life-full support system and the spacecraft's environmental control systems are being tested at a new facility opened by ISRO. At 10,000 crore rupees, Mission Gaganyaan is India's biggest space mission so far. Between 2022 and 2023, ISRO will send India's second mission to Mars, the Mars Orbiter 2. It will have an orbiter and may include a lander and a rover. ISRO will also send an orbiter mission to study the atmosphere of Venus that is made up of carbon dioxide. The Chandrayaan 1, a flyby mission around 400 kilometers over Venus by 2023, will study the dense, hot atmosphere of Venus and the planet's surface using a probe. And then comes Chandrayaan 3, a joint mission of ISRO and the Japan Aerospace Exploration Agency to the Moon's South Pole in 2024. ISRO's biggest endeavour will be India's own space station. A detailed project report will be submitted to the government after the Gaganyaan mission. According to K. Sivan, the proposed space station will weigh 20 tons where astronauts can stay for up to 15 to 20 days. It will be in orbit 400 kilometers above Earth and launched 5 to 7 years after Gaganyaan. Bureau Report, Rajya Sabha Television.
So that's it from us in this edition of In Depth. We'll be back same time tomorrow with a detailed analysis on some other subject. In case you missed the television broadcast, you can also watch our program online on YouTube as well as Twitter, the link for which is given below on your screen. Suggestions and feedback about the program are also welcome. Thank you very much for your time.
देखिए